All right. Welcome back, everybody, to week two. I believe it's day eight, six, seven, eight, nine. Day nine, right? Yeah, day nine, I think. Foundation programming. I'm gonna lose track of these days as every day goes by. We left off yesterday where I found you guys the line segment.py. So today we're gonna pick off from where we left off with a walkthrough of the assignments. Um, and then afterwards we will move on to our next assignment. Right. So if at any point you guys have any questions, do stop me and ask away. If there's anything that you might have struggled with, or if I have some kind of difficulty with it, let me try to help out and whatnot. All right, so let's go ahead and get started. Here's our reading. So we're gonna go ahead and read from top to bottom and just work our way down. Right. Let's see. All right, so we're gonna write a class name points that has two data members, which were X chord and Y chord. So I'm going to define my init method, which is the method that my class is going to utilize to create itself when I run the point class. I'm going to give it the X chord argument and the Y chord argument, or I guess parameters, right? And then I'm just going to go ahead and assign this in here as private data members. All right. And that's because it only takes two data members, right? X chord and Y chord, representing two coordinates of the point it should have. So the name method takes the two arguments and utilizes them to initialize the two data members. I should create two get methods for the data members, one for get X and get Y. So we're going to create our getter methods. Define get X chord. And all this is going to do is return self dot X chord. And then same thing with Y, get Y chord, and return self dot Y chord. Cool. So there goes my getter methods. And then I should create a method named distance to that takes a point object as an argument. It returns the distance between the point object the method is called on and the one in front of the dot, and the point object passed as the argument, right? So essentially, I should be able to do something like this, where I'm going to create a class object for point. I'll just call this point one. And I'll set this coordinate to 0, 0. And I should be able to create a second point where this one is 1, 1. And when I create this distance to method, right, this method is going to belong to the object, right? Define distance to. This method should take a point object as an argument, and it's going to return the distance between the point object the method is called on, right? So whatever object instance calls this, right, we need to be able to grab that distance to the person that's being passed in as an argument, right? So this should be something like this, where the argument distance to is going to take should be point object. And I should be able to do something like this, where I can assign it a class. Or I do like class. Where's the object? Hold on, stand by. There we go. So I'm able to do something like this. I don't know if you guys know what this is, but essentially, whenever you define parameters or arguments, you can add certain keywords to point out what type of data type this should be. For example, take the X coordinate and the Y coordinate. When I'm creating a definition of these parameters, I can do something like str, right? So I know X coordinate should be a string, or it should be, which actually it should be an integer. All right, so this doesn't do anything, right? This doesn't lock the data type of what this parameter should be. It's more of like a comment, right? It lets other people or other developers know when they're reading your class definition, oh, okay, this parameter should be some kind of integer, right? So that's all this is doing. And then that's the same content here. When I'm creating this method called distance to, and I assign this argument, I want to make sure that everyone that reads this knows that this should be an object that's being passed in as an argument. All right. And as we read here, the distance to method should take a point object as an argument, and it's going to return the distance between the point object the method is called on and the point object passed as the argument. So I should be able to do something like point one dot distance to point two, right? There we go. So the first object, point one, should be able to utilize the distance to method it has and pass in the point two, which is the object, as an argument, and be able to compare both of these distances, right? And the way that we do that is whatever method is going to call this, or I'm sorry, I misspoke, whatever class or object or instance, really, the keyword here is whatever instance is going to utilize this, that's the self, right? That is self. So when point one uses distance two, it's going to run this code. It's going to see self. It's going to say, okay, myself, self dot y chord, right? And then we can compare point object dot get y chord, right? Something like that. And then we can compare both of these. Right? Does that make sense? Now, how do we actually get the distance between these? For example, if point one and point two are both point objects, then the point one to distance to point two should return the distance between both of these. For this method, you'll calculate the distance using the following formula, right? So we have to use this formula, which is a distance formula.png. You'll find that within the directories of where this assignment is located at, right? Distance formula. And it should be an image. And here it is. The image is as follows, right? The D is going to stand for distance. And as you can see here, it's taking two X's and two Y's, right? I should be able to grab the X for one point and subtract the X from the other. And the same thing with the Y's, right? Get the Y from one point and the Y from the other. And then after doing all this math, I should be able to get the distance between these 2 points. So arithmetic in Python works just like arithmetic in the regular world, right? So it's going to go by PEMDAS. So as we know, PEMDAS, right? The first thing in this rule is that it's going to take care of the P, which is going to be the parentheses, right? So whenever I run this, the first thing that's going to run is going to be whatever is in these parentheses. So it's going to do x2 minus x1 and y2 minus y1. So when I grab these, I should be able to do the math for both of these. So we'll tackle it one part at a time. We'll get the difference between the x's and the difference between the y's. So we should say, we could do something like this. We'll do different variables. X difference is equal to, and I'm going to say that x1 is a point that's going to call the method, and I will assign x2 to the point that's being passed in as an argument, just so I don't confuse myself, right? So for the sake for you guys too, who are watching this from home, we'll say point one is equal x1, and we'll say point two is equal to x2, right? So with this in mind, I should be able to say self dot x chord. And if I do this backwards, it should be point object dot get x chord minus the x chord of the object that's calling this method, right? So in this situation, point one, which we already determined is going to be my x1, is the object called this method. And I'm going to subtract that from x2, which is the object that we're passing within here, right? This makes sense so far? Cool. Now, once I get this, whatever comes back from this subtraction I'm going to do it to the power of 2, which as we know is 2 exponents, right? I'm pretty sure. Correct me if I'm wrong. Math is hard. But I should be able to do to the power of
That's
2.
right.
Thank Nick. Yeah, so subtraction, and then we do to the power of 2, and that's going to take care of the x difference. And then finally, we're going to do the same thing for the y. So we'll say y difference is equal to, and same constant, point object dot get y coord minus self dot y coord, and then to the power of 2, right? So notice that we're leveraging the get y coord when we are using the point object that's coming as an argument, because they're both classes of point. They both have these methods. Now they are their own unique version of this class. So whenever I call these methods, we are going to get different results back, right? But that's okay. The point is the functionality still the same. Think of it almost like twins or siblings. They're both children of a parent, so they probably have very similar features. They might do certain things. They might not be exactly the same. They're unique in their own way, but they still share similarities to the parent, right? Something like that. That's kind of a nice analogy you can use. So that takes care of that. Finally, we're going to add. So we can say distance is equal to the addition of the y difference and the y difference, and then square roots. So we will say x difference plus y difference, and the square root should be 0.5, if I remember correctly. We can check back to the reading. I think I have it somewhere here. I think we did it the standard deviation. But correct me if I'm wrong, guys. This should give us the square root. But that should conclude the distance too, right? Um, and just for the sake of demonstration, I'm going to run this. And of course, I'm not printing this out, so I'm not going to get any feedback. Let's go ahead and run it again.
You need
Uh,
to. I think you need to
yep,
return it.
I do need to return it. Absolutely. Yeah, nothing's being returned from this method. So obviously, when I try to print it, because the method doesn't return anything, it's going to show none. And there we see the distance between both of these. Uh, it's actually a little, that's kind of weird. I don't know how that makes sense, but I don't know. I'm not a mathematician.
That looks right.
Ah,
If you want to make it real simple, on the point two, change one of those numbers to zero, and it should just come out to a flat one.
the point two
Line
right here.
23. Yeah, either one of those, change it to a zero, save it and run it. Should be a flat one.
Hey, right on. Nick, you're smarter than me, my man. But all
I don't
right.
know about that.
So we have this, right? The points is done. We can move on. All right, so the above formula requires taking the square root, as you might recall. You can, oh, yeah, we did this. Awesome. We can move forward. Next, we're going to write a class named light segment that has 2 data members, an endpoint 1 and an endpoint 2. That's going to represent the 2 endpoints of the line segment it should have. If you guys recall yesterday, we did a TL draw of what that's supposed to look like. Give me a second. Let me see if I can pull it up. Um, do I not have it? Uh, hold up. Wait a minute. Something ain't right. Here we go. All right, so we did a little TL draw because I know this assignment can be a little bit confusing. But we just created the point class, which essentially has x and y for both of these. This class has a distance 2, which, as we just saw, was able to give us the distances between both of our point objects when called to each other, right? So we have this. The next class we're going to do is going to be the line segment class, which is going to take an endpoint 1 and an endpoint 2, which are essentially going to be objects of our points, right? So we're going to use objects to create another object. Now, with that in mind, let's go ahead and create this class. So this is going to be class line segment. And once again, we have to describe the init method, which is going to take endpoint 1. It's going to take endpoint 2. Let's read through it a little bit. An init method that takes 2 point objects as arguments and uses them to initialize the 2 data members, endpoints of the line segment. So actually, let's change this a little bit. We'll call this point 1. Actually, no, it's fine. We'll keep it like that. Makes more sense this way, actually. So we'll keep endpoint 1 here, and then we're also going to give it the little notation here to let other people know that this is an object. So when they're coming through here, they're aware, right? And then finally, we're going to create our data members by assigning the endpoints. Make sure they are private, right? There's our init method. Next, we're going to get methods for the 2 data members, get endpoint 1 and endpoint 2. Pretty standard. Get endpoint 1. Go away. Return self dot endpoint 1. Define get endpoint 2. Right on. Okay. So these are getter methods. Cool. Standard. Next, we're going to create a method named length that's going to take no arguments. It's going to return the distance between its 2 endpoints. This can make use of the points distance to method, right? So we should be able to create a method called length. Takes no arguments, but even though it takes no arguments, it still requires self. So it knows that this method belongs to this class, right? So it requires self, and it's going to leverage the distance to method from the point. Well, what is this right here? What is the data type of this? As we know,
It's an object.
it's an object, right? It's going to be some instance of an object. So because it's an object, I can treat it as such, right? So I should be able to do self underscore endpoint 1 dot distance 2, right? And then pass in and self dot underscore endpoint 2, right? Even though they're described as data members, right? We have the self. It might look a little forward, right? You might be a little uncertain. At its core, they're essentially just variables, right? Data members are just variables. And these variables are holding the object instances that we have of points, right? We passed in complete instances of objects as arguments whenever we create this line segment. So because of that, they come with a method. So we can use them as such. And then I can say length is equal to, or I could just literally return whatever comes back from this, but I'll make it a little bit more readable. Return length, right? So that takes care of length, right? I pretty much already created this method just by using that. The next part, I think probably the most confusing part is these two. The next method is going to be is parallel to. Let me just go ahead and write it out real quick. It's parallel to. This method is going to take a line segment object, right, as an argument. So very similar to how point was able to take in another point, which was an object, as an argument, and then compare the distance to it. We're going to do something fairly similar here. So line segment should be able to take another line segment within the parameters and then do something with it, right? So within is parallel to, we're going to be able to take a line segment object as an argument. So let's go ahead and add this in here. Line segment obj, and then I'm going to give it the notation here. It's going to return true if the line segment, the method is being called on, is parallel to the one being passed as the argument, right? Otherwise, it should return false. So I can just say if parallel, return true, else return false. And this is just for my own notation here, so I can understand the problem. For example, if line segment 1 and line segment 2 are both line segment objects, then line seg 1 dot is parallel to line seg 2 should return true if those two line segments are parallel, but otherwise should return false, right? So it's the exact same way that points worked with the distance 2. For this method, you'll calculate the slopes of the two line segments and compare them. If the two slopes are equal, then the two line segments are parallel. Otherwise, they are not. So we need to calculate the slopes of the two line segments and compare them. If the two slopes are equal, then the two line segments are parallel. Otherwise, they are not. This can make use of the following slope method. Right, so we don't have a slope method yet. So I think we might have to put this on pause for now. I'll just put pass here so it doesn't give me an issue. So let's go ahead and check a method named slope that takes no arguments and returns the slope of the line segment. So before we do is parallel to, let's create another method called slope, right? Because it's trying to get us to take advantage of it, and we're trying to adhere to the dry rule, do not repeat yourself. So might as well just create a method for this and then just call the method just like we did with the length method, right? So we'll say define slope. And the slope method takes no arguments, but it's going to return the slope of the line segment, right? So I don't know how to do slope, but we have a slope formula PNG as well, just like we had the distance to. Right, M should be the slope, and it's going to take the difference between the y points of each endpoint, and then the difference between the x axis, and then finally divide these two, right? So we can say once again, y difference is equal to, and honestly, I'm just gonna go ahead and copy and paste this because I already created up here, right? Ain't no reason to work any harder than I gotta work. Actually, this might be a little weird. Never mind. It's gonna be different syntax. It's gonna have to be self dot endpoints, right? So I'll say y difference is gonna be self dot underscore endpoint 2 dot get y chord, right? Because this is a point object, right? And as we know, the point object has to get y coordinate as the getter method for me to access that y coordinate. So if I want to grab the y coordinate for endpoint 2, like we have here on the top left, I need to use the get y coord, and I'm going to subtract what returns back from self dot underscore endpoint 1 dot get y coord. That should give me the y difference. And then we're going to do the same thing for the x difference, but we'll use for x instead. Right? That gives me the difference from both of these. And then finally, we'll say slope is equal to get y difference minus, oh, my bad, divide x difference. Right? This should give me the slope. And then finally, return slope. Right? We're dividing the differences of y's by the differences of x's, given the slope. Now, with this in mind, now we are able to use this to, and within our is parallel to method. All right. So returning to the parallel method. If the two slopes of our line segments are equal, then the two line segments are parallel. Otherwise, they are not. So essentially, we need to leverage the slope method for each one of these line segments and just really compare them to see if they're equal. So we should say, let's see, if self dot, how would do this? self.slope. I think so. If self.slope is equal to lie segment underscore obj dot slope, return true. Else return false. It should look something fairly similar to this. The method calling this is the method that's running the is parallel to. So we have to run the slope method. And then the object being passed into the argument should also invoke its slope method. So we should be able to compare these. Now there's a little note here where that you shouldn't test two floats for exact equality because if possible, a possible lack of precision or round off errors. Instead, you need to compare float values for equality. If you need to do it, you can do it like this, where you take the absolute version of num1 minus num2, and you check if it's less than 0.00001. So we should say something like this, where we say if absolute of self.slope minus line segment obj dot slope is less than 0.00001. I mean, just for readability, we'll see how this. We'll put this in parentheses. So this will run. Let me move this out of here. Put it here. There we go. Once it gets to this method here, it's going to put the slope of the class that's or the object is calling this. It's going to grab the slope of the object as an argument. It's going to take this both of these differences and to get the absolute value of it, and then it's going to compare it to see if it's less than 0.00001. If it is, we're going to return true, else we'll return false. And that is going to conclude this assignment. I don't know. Well, actually, if these are parallel. This should work, right? Tell me yes or no, Nick.
Yes.
All right. Something like this. Actually, these are points. I hate this. You have an example on you, Nick, that you might have written?
If you look in the README, there is a section you can copy and paste. I think it's a little higher up. There you go, right there.
Oh, thank you. I appreciate it. I figured there was. I just didn't remember.
Yeah, they didn't put it at the bottom, so it's like I didn't see it the first time either.
Oh. Let me actually go into the actual reading because this is a little ugly. There we go. Okay. Let's go ahead and get rid of this. And we should be good. Let's run this. Let's see what it gives us back. What are you talking about, Willis? Oh, what am I doing? Sorry, give me a second. What is going on? I'm just gonna destroy this terminal. It's parallel to. They shouldn't be parallel, right?
Yeah, those are the exact answers I got.
All right, yo, right on, dude. First try. All right, cool. Any questions? Nobody asked any questions about the entire team. Everyone understand the way that I reached the outcome or how I did this?
I just need a lot more practice, but the concepts make sense.
All right. Okay. Cool. Okay. Yeah, so that's gonna conclude the line segment. Before we go into the next one, I believe the next one's gonna be streaming service. Let me go ahead, give me a second. Sorry. Let's see. Let's open up this class schedule. We were doing classes and objects, and we got pretty far actually. Too far. Uh, right. We did line segment, and the last one is streaming guide. But I feel like we could use a little more help. So I have concocted a exercise which will be dropped in the Slack channel. I believe we should all be in there. It's going to be within a code block. Go ahead and I want you guys to create a new Python file somewhere in your object-oriented programming folder or for whatever lesson it is. I believe it's lesson 8. And then copy and paste this into a Python file. It's already formatted for you. And we're going to talk about this assignment before we break off and give this a try. Let me know when you guys are good. Just give it a thumbs up. Emote if you guys want. Once you guys have it. I should still share my screen just in case. Okay. All right. I'm assuming we got it. I see an emote. So before I release you guys to try this out, this is gonna be your inventory management game using Python. It's a very simple. It won't actually open up nothing crazy for you. It's just a game with code, right? So you're gonna build a simple object-oriented program that's gonna manage a backpack inventory, right? You're gonna have a couple of classes, right? The scenario is that you are an explorer preparing for an adventure, right? And you need to pack essential items. Your backpack, which will be your pack class, has limited inventory slots, right? Think about video games, right? When you play role-playing games, you don't, well, unless you're playing something like Skyrim, right? You don't have an infinite amount of space in your inventory. Um, Even then, actually, no, Skyrim has limits. Never mind. I'm thinking about something else. Well, I mean, some items, right? Like miscellaneous items, you can just take a bunch of books, whatever. But you have a limited amount of space, right? So your pack class should have a limited inventory slots. You should have a max weight, a max volume. So you must choose carefully what to carry. Let me word wrap this. There we go. Right. Here are the requirements. You're going to create 2 classes. One is going to be your inventory item, right? Which should represent an individual item. The data members will be a name, a weight, and a volume. At the very bottom of this exercise, you will have some predefined items, so you don't have to make these up, right? We have like arrow, which weighs 0.2 pounds, volume, which has a volume of 0.5, right? Because we know stuff has volume, so it takes up space in your backpack, right? So even though you have like, arrows weigh a small amount, if they're big and bulky or long, they're going to take, some space. So you have to account for that. Your pack class is going to store inventory, but it's going to have a max weight, a max volume, and inventory slot limits, right? So let's just say for the sake of having a limit, we're going to go with 10. So just have a max limit of 10 items. Now, how you store these items, it's going to be up to you, right? You know Python, so you know data structures. You know that some data structures are better for working with certain data, right? Whether how it's going to depend how fast you want to access these items, how you want to retrieve these items. So you as a developer, you need to make the choice to know what data structure you want to create to store these items for easy accessibility, right? So whatever data structure you decide, created data structure is going to hold these items, right? Your pack should have a couple of functionalities. It's going to have an add item method, right? It's going to add an item if the limits are not exceeded. So if you have inventory slots, if you have not exceeded your max weight limit or the max volume limit of your pack. You should also have a remove item, right? It's going to remove an item from the pack. It should take an item name and then removes it. You should have a show inventory method, which is going to display all the items and total weight and volume of your pack, right? So how you think you're going to do that? It's going to depend on your data structure. You might have to do some kind of loop, right? Probably the way of doing this is to go through a loop, iterate through your items, and then print out what they are. You should have a current weight, a current volume, which that should be keyword for a getter function, right? So you should be able to grab your weight and your volume, but you should not be able to create a setter for this, right? You shouldn't just change the volume of your backpack. You don't just magically increase the volume of your backpack, so this should not have a setter. Your inventory item should be pretty straightforward. It's just going to have name, weight, and volume, and then some getter methods so you know what the name is, the weight is, or the volume. Once again, no setters. You don't just magically change the weight of an arrow, right? So getter methods, but no setters. Which, by the way, if you haven't caught on to this, when you add an item to your pack, it should be an object, right? Pretty straightforward. Finally, you're going to have one more class. This is going to be your game class, right? Your game class, you're going to create a game class that lets the players interact with your inventory, right? Your game class should be able to create a pack instance, right? So essentially, what you're really going to be running is the game class, right? Your game class is what's going to take care of this functionality of creating an instance of your pack. And you're going to have a method that should be called something like run or run game, whatever makes you happy. Call it whatever you want. That's going to run this game in some kind of loop to allow you to do all these things, right? So think of maybe a while loop with a condition statement, right? The players would choose items from a menu, right, to add to their pack. So you should probably have some kind of input method to take input from the user as your game is running, right? The pack's going to fill up as items are added. After every new item, show the state of your pack. The game continues until weight, volume, or inventory slots are exceeded, or you decide to stop playing, right? So you should be able to provide the user with menu, tell you to choose from your menu whether you want to choose an item or you want to quit. And you should be able to continue interacting with it until you either say quit or until you exceed the limits of your pack. Do you have any questions on this assignment? Interesting? Okay. All right. We'll take about a good solid hour on this. We're gonna go into our breakout rooms. Let me go ahead and stop the recording. All right, guys, welcome back. So we just spent about an hour giving this assignment an honest try. And I saw a lot of confusion, right? So what we're gonna do is we're gonna take a couple minutes, and I'm gonna kind of start you off and push you in the right path to ensure that we all understand kind of the concept or how to go about this before I get you back into those breakout rooms. So what we're going to do is I'm going to create your inventory item, and I'm also going to create the game class. So we can get something working and kind of show you how this loop should kind of work. Right. So what I'm going to do is I'm going to create my inventory item class first. I'm going to say inventory item. And like, as we know, a class requires an init method, right? An initialize method that it's going to use to define itself. It's going to require the keyword self. It needs a name, a weight, and a volume, right? Every item that we create, every instance of an item should have a name, right? A weight and a volume. If we create an arrow, right? We know it's called an arrow, so it should have the name of arrow, its weight, volume, whether it's rope, whether it's a sword. They're all a form of an inventory item. They all have unique names, but they're all a form of an inventory item, right? Think back to when we were talking about the pets, right? I could have created a pet class, but there might be a different species. One might be a bird, another one might be a dog. We might have a cat species. We might have different types of other species, but they all derive from the same class, just like you guys, right? I can create a person class. One person instance can be Michael, another instance person can be Daniel, and so on and so forth. You're all essentially a type of a person, but you all have individual data members, right? That defines who you are uniquely. Does that make sense? So this is very important. So this inventory item is going to allow us to create different versions of an item. So we're gonna give it name is equal to name. Self dot weight is equal to weight, and self dot volume is equal to volume. Okay, let me go ahead and make this private because that's the proper convention here. And then when it comes to the setters or getters, these should have a getter method, right? I shouldn't be able to change the name of an arrow because arrows are just called arrows, right? They're not ever going to be called something else unless they're like a unique specific arrow, right? These are predetermined or predefined. Same thing with their weight and volume. So we should just be able to grab this information but not change it. So all we're going to do is give them getter methods. We're going to say define get name and say self dot return self dot name. And I keep opening up this Python. Define get weight return self dot weight, and then define get volume and return volume, right? All this pretty self-explanatory, very simple. All right, let's go ahead and create a game class. We're gonna keep the pack out of this for a little bit. I don't want to confuse you guys too much yet with a pack, but we have a way of creating inventory items. We have the class, we have the structure, the blueprint for it. Let's go ahead and create a game class so we can kind of get something on our screen here and we can start working with something. So I'm going to create class game. And this should have an init method that's going to take no parameters. It still needs self, but it's going to take no parameters, right? When it runs, it's supposed to create an instance of a class for pack. Now, because I haven't created the pack yet, I'm not going to add it here. But it should say something like self dot game pack, or just you can just call it pack. It's equal to, and then you would call the pack class and create an object that's instantiated the moment we create a game. Right? When you guys open up Call of Duty, when you guys open up these games, they automatically create objects of the stuff that you utilize, the menu object, right? You have different objects that do these different things. We can do the same thing with game. I'm getting an error here because class of pack is not defined. I can probably do something like class pack. I'm just gonna add a init method here so I don't get an error. And I should be able to do pass. And there you go. I'm not getting an error, but I already have it here. By default, this should pass and create a pack object the moment I create the game object, right? Because as we know, the init method runs when the class is called, right? This is how you create that object. It uses the init method to create it for you. This pack object, obviously, it's nothing, right? It doesn't do anything for us because there's nothing defined here. I just put pass, but it's still going to be a pack object, right? Let's continue with the game. We're supposed to create a method that runs the game. So let's go ahead and define that method. We're going to say define run. And this requires self. So this is going to be my run method. This is going to have this loop that's going to prompt my user for information, right? And to do this, we'll say something like, I can say running is equal to true. And then I can say while running is equal to true, I want to do this following. Or I can print something like choose an object or choose an item. I'm gonna keep it very simple. I'm gonna do some restructuring in a little bit. And I can say one is arrow, two is bow. Something like this. And then I can say something like new item is equal to and I'm gonna take input here. Or let's not call it new item. I'm gonna say selected item or selected menu item. right? Because this isn't going to be an item. I'm just letting the user choose something, right? I want to prompt the user for some input. He's going to get this menu, this print message that says choose an item. Number one is going to be arrow. Number two is going to be bow. So that means I should get a string that's either going to be one or it's going to be the string of two once the user decides what he wants to grab. Make sense so far? Now, with this input, I'm going to convert this. Actually, I don't even have to convert it. I don't think I got converted. I can keep it like this. I'm going to use the input that the user gives me to create something. I can say if selected menu item is equal to 1, then I'm going to create a new brand new item. New item is equal to inventory item. This should be an arrow with a weight of 1. Or actually, we'll make it a weight of 0.5 and a volume of 1. So I will only create this arrow if my user decides that he wants an arrow. How do I know he wanted the arrow? Because the input he gave me was the number 1, right? Which is on my menu for the arrow. Make sense so far? Then I'll say elif selected menu item is equal to 2. I'm going to create a different inventory item, but this was going to be a bow with a weight of 1 pound and a volume of 2.5. Right? If I don't get a 1 or a 2, then that means he didn't give me a selection. So all I'm going to do is I'm going to quit. I'm going to say running is equal to false. Right? That means he didn't choose something that he wanted to create. So chances are that he gave me the word no, or he just wants to do something else. And that's not a valid option. So I'm going to go ahead and quit. Right? Running is equal to false. And then the next time this while loop runs, it's going to stop. Let's give this quick little demo a try. Let's see if it works. I'm going to create a game. I'm going to say my game is equal to the game object, right? It doesn't take any kind of input in the initialization method, so I don't need to give anything here. And all I'm going to say is my game dot run. And let's see how this is working. Let me stop pressing the run button because that's not how I'm teaching you guys. I'm going to say Python main.py. There we go. Here I have my menu. Choose an item. 1, arrow. 2, bow. Did I press the 2? Where's this 2 come from? Oh, my bad. I see what I did. This should be empty. Okay. Let's go ahead and run it again. Let me clear this. There we go. Choose an item. 1 or 2. I press the item. I didn't get an error. So actually, let me go ahead and do a print statement. I can say something like print item successfully added to your inventory. And I know it hasn't been added to my inventory because I don't have a pack yet, but I just want some feedback so I can show you how this game look should work. Right? And then I'm also going to print out this new item so we can see what it looks like. All right, back again. And I'm not going to print the object. I'm going to print the object name. And I know I have a getter for that, right? Get name. So let's try that out. Choose an item, arrow or bow. Item successfully added to your inventory. And look at how I'm printing out the name of the item. This time I'm going to choose bow instead of arrow. And I didn't add a print statement for that. But does everyone see how this is working? Right? I created this menu. And I'm allowing my user to choose arrow or bow. And I typed in box, not bow. Horrible. And then depending on the user selection, I'm able to create a different object. Here's my arrow, here's my bow. I'm making multiple bows. Here's my other arrows. And I'm just adding multiple different, oh, there we go. I added a input I wasn't tracking for. I put 12. But I was able to create multiple bows or multiple arrows, right? Whatever the user gave me, I use that condition. As we know, we can use conditions. And then depending what selection the user chooses, I'm going to create one object or another, right? I saw a lot of you guys trying to like create a whole menu, already hard coding every single object, but you don't necessarily have to create it right off the bat. It should only be created when the user tells you he wants something new, right? We should not be creating instances of objects, right, when we don't need to. They should not be hard coded in the global scope of your code. It should be within the game, right? You should only create this item whenever you need it. So, anybody have any questions so far about any of this? Ask away. I saw a lot of stuff happening. Nobody has any questions. Why did I do something in a certain way? Nothing like that. Nothing about any of my code, about any of the methods that you are asked of you to create. I'm gonna start you off with the pack. Right. Let's look at the pack. So we have our inventory item and we have the pack. The pack, it has a couple items here. It has more than the inventory item. Right. When my pack is created, it needs a couple of items. It's going to require the name of my oh my bad, this is the inventory. Here you go. The pack is going to store inventory, but it has a max weight, a max volume, and an inventory slot limit. All right. So let's do that. So there's two ways you can do it. You can, one, make this class customizable and take in a max weight if you wanted to, or a max volume. Right. This would make it so you can create different types of packets, like backpacks. Some can carry 30 pounds, some can carry 100. Right. This is how you are able to customize different versions of your backpacks that a player can have. I'm not going to do none of that. This player only has a default pack, and that's it. Nothing else. So I'm not going to allow the user to add input into my initialization method. By default, when someone creates a pack class, it's going to run the init method, and it's already going to have a predetermined data attribute of max weight set to 15. I'm going to give it a max volume of 15. I'm going to say a max item count is equal to 10. You can only have 10 items in here. So what that means is I could probably have 10 arrows because the weight of an arrow is 0.5, right? Yeah, 0.5. And the volume is 1. So I can add 10 arrows. So that's how many items I can add here. And it still won't exceed my max weight or my max volume. But there might be some other items that weigh like 3 pounds or 5 pounds, like a sword. So I might be only able to add like 5 swords before my max weight or my max volume reach their limit. So I have a max weight and I have a max volume, but should I probably track how much weight I currently have as well? I know how much I can carry, but I should probably know how much weight I have. So there's a couple ways that you can approach this. One, you can create a variable called current weight. And when you first create this pack, it by default should start 0, right? Who buys a backpack that comes with stuff in it? Nobody. So the backpack should come empty. So the current weight should probably start off at 0 when you create this pack. And probably same thing with the max volume. So this is one way you can do it. Oh, my bad, current volume. This is one way you can do it. Or what you can do is when you create a getter method to grab your current weights, you might, if you don't have a data attribute, you would have to go through every single item, check their weights, add it up, and then return it to the user. That seems a little bit more manual labor. What if I just create this attribute called current weight, and then every time I add something new, I just increase it? That way I don't have to have a for loop somewhere else, grabbing every single item every single time. Just call this method. Creating a variable that holds your current weight or current volume sounds like a much better way of doing it. But what attribute am I probably missing from my pack? I have the max weights, the current weight, max volume, current volume, and I know how many items I can carry. But there's something very important here that I am missing.
Current items.
Yeah, current items. Where am I storing these items? I know how much I can carry, but I don't have anywhere where my items are going to be at. So I want to probably create something like self dot current items, right? Or you can call it whatever you want. Items in pack, whatever makes your heart happy. I'll just say current items. And these should all be max item count should be private for sure. Actually, all these should be private. So let me go ahead and make these changes. I do apologize. They should all be private data members. So we have our current items here. So I need somewhere I can keep track of the objects that I'm adding into my pack. And notice I said objects. That you should not be tracking a list of strings, right? You need to be able to track the entire object because that's the whole point for your objects, right? The fact that the objects can consolidate the code of the name, its weight, its volume. Right now, that's all it has, right? If your system got more complex, your program, your game, you might also have like attack damage, right? You might also have like durability. You might also have a wide range of different things. Your weapon should be able to attack. Your weapon should be able to probably block, stuff like that, right? If it's an arrow, it probably should have a trajectory that it flies in, or speed, or stuff like that, right? Wind resistance, uh, aerodynamic, whatever you want to create. There's probably different variables that go into it. So when you add something to your pack, it should be an object that is able to consolidate all these variables that belong to that item, which is why we use objects, because they allow us to format our code in this manner. So our current items, we can save these items in two different ways. What two data structures do we know that we're able to save large pieces of information in? Not your question.
List.
Yeah, a list or a dictionary, whichever one you decide to go with, you should probably go with that one, right? So yeah, we can most definitely let's do a list to keep it fairly simple. We can definitely do a list, right? We can have a current items that's gonna have a list of objects. Now, I want to make sure that you guys tracking this. Whenever you create lists and you're tracking objects, and the objects have other values inside them that might have lists, or if you create dictionaries, always add a comment here so you know what it has in it. I'm gonna say list of item objects, right? Inventory, because you're bound to forget what's supposed to go in here. I promise you. If you visit this code again in a week, you might forget what's supposed to be in here. Especially imagine you have a game and you have thousands of items in your game. Potions, mana potions, swords, all types of swords, axes, bows, crossbows, shields, large shields, small shields, bucklers, helmets, chest pieces, all these items and different variations of them. So it's always important that whenever you start consolidating large pieces of stuff like this, of different types of objects or whatever, you make sure you annotate what's supposed to be in here because you're going to forget. Always add some good comments. But here is my current items, right? So here I should be able to add list of inventory items, right? And then in my init method is going to create this pack that's going to have all these data attributes. As of right now, my pack doesn't have anything. And this is where I'm going to turn it over to you guys. I want you to continue from here and finish off the pack. Add item, remove item, show inventory, current weight, current volume. They should all be abilities that the pack can do. If you add an item into your pack, what do you need to make sure before you add it into the pack?
You can carry that item.
Yeah, do you have enough slots? So if you want to check how many slots you have, you probably have to check the length of your current items. Make sure it doesn't exceed the max item count. So when you go to create your add item method, you may have to do some kind of if else check or a conditional where you're like, if the current item list is less than 10, and if the weight of your item plus your current weight does not exceed your maximum weight, then you can add the item, right? So these are conditions you have to double check before you just go ahead and start dumping stuff in there, right? And that should be enough for you guys to finish all this assignment and get this working. Do you have any other questions before we break off into the breakout rooms again? Okay. All right. Take the breaks as you see fit. We're gonna come back at 7 or at 8:40, and I would like a volunteer to demonstrate their code. Sound good? Okay. Hopefully this is enough to go off of. Let's go ahead and stop the recording. All right. How was it? Thoughts?
My daughter enjoyed playing the game.
Yeah? Okay, that's good, man. That's good. Anybody else? Daniel Chasmar, would you ever complete it? I know you said you had some issues.
Yeah, I mean, it compiles, but it just doesn't run. Like it won't pop anything into the terminal.
Let's see it. We'll take Daniel's example, see how it works, and maybe we'll check out Nick's too.
So
Let's see your game class. Okay, I see you're calling game. Scroll down.
Mm-hmm.
You need to create an instance of game, right? The same way that you created an instance of like a pack or whoa. Okay.
Yeah, see, I wasn't sure how to combine these because I created a new item in the pack just to try to make the add the item thing work.
Right. So you see here. No, don't move. Don't move. You see how you are creating instances of these inventory items. They're calling
Yes.
that class name, and then you are creating something. And then you're assigning it to some kind of variable, right?
Yes.
And then you can do something with it. That's kind of what you want to do with game. Also, this you should not be calling the pack class directly. You want to call the object, the instance of the class. So I showed you on the very top of the game class, right here, right there, self.pack. You should be using self.pack. That is the field that currently holds a pack object, right? The instance of this pack. Does that make sense?
Not really. Not
Okay.
following.
Yeah. So, actually, I will work with you in a little bit, Daniel, and I'll show you. Does that sound good?
Yes.
Yeah, awesome. Nick, let's get your demonstration. So we can move on from here, and I can let people go.
Let me know when y'all can see the screen share.
I can see it.
Okay, do you want to see the program run first or to go through the code itself?
Run it.
Okay.
Packer sack.
What do I call this? Inventory. Okay. So you have 6 options. The 6th is Q to quit. You can 1, add an item, 2, remove an item, 3, show current inventory, 4, show current weight, or 5, show current volume. Which one do you want?
Let's go ahead and show our current inventory.
Current
Show
inventory.
our current weight, and then show our current volume. So inventory is empty. Cool. What's your weight? 0. as like expected. And same thing with volume. It should be volume. Okay, awesome. Let's go ahead and add an item.
Want to add an arrows
Uh,
1, bows 2, etc.
I tend to be an archer, so let's go ahead. I want you to add a bow and an arrow.
Show current inventory.
Yeah, show current inventory. Current items inventory, bow and arrow. Right on. Okay, cool.
Weight is
Uh,
2.7. Volume is 3.5.
yeah, I see Michael get a little smirk like, oh, that's cool.
It,
Yeah,
it when it,
awesome.
it takes a while, and then when it comes together, it feels really cool.
Yeah, it absolutely, absolutely. Let's add another item. I want to make sure I have a close melee weapon in the event that they close their range on me. So let's go ahead and add a sword on here. Okay. Okay, dude, right on. Let's do the weight and volume.
7.2 and 8.5 volume. So
All
mine is
right,
set to 10. So if we go above,
sure. Then let's do that again. I like dual wielding, so I'm gonna go ahead and carry another sword. So go ahead and add another sword. Oh, dang it, I do not fit. Okay, well I can do without maybe a bow and the arrow because I ended up not liking being an archer. Kind of lame. Let's go ahead and remove an item. Can we do that? Oh, it quit.
so yeah, I
Okay,
had it to where it quits when you reach those limits. Here, I'll
sure.
run it again.
Right on. No, it's fine. Right on. That's good.
So add
I
an
saw
item.
add
Sorry,
an arrow, show me inventory, and then delete an item. Remove item, show inventory. Dude, right on. Okay, yeah, exactly how it's expected to work. Good stuff, dude. Yeah, so let's go ahead and look at some code. Just kind of walk me through your inventory item class, your pack class, and then a little bit of your game logic.
okay.
Just like top level explanation.
So so for the whole running the game and setting it to a variable, it works either way for me. I don't know if
Let
that's
me let me see your methods. What'd you do?
so game starting with game starts right here. Class game.
Yes, that's why, right? So, uh, it's not wrong. I'm not saying it's wrong, but it's not right either. You want to have a method that does this on command. The reason why it does automatically is because it's not within the structure of a method slash function. So
Gotcha.
by
Oh, okay, so
default,
you want a method inside game to where I
right?
can create an instance and then game dot run or something like that.
You don't have to. But
No,
ideally, you would want your these methods to be only when you need them to run, right?
okay,
But yeah, that's why it's running automatically because the moment it creates this game class, it initializes it, and then it gets down here and like, oh shoot, all right, let's start running, and I start the while loop, right? That's why it was running the way that it is. And then yeah, all that from line 98 feet below should be indented to the right, and now it won't run. You have to call the run method individually.
yeah, on game, right? So
Yeah,
game.
game dot run, and you have an issue above. Go back to your right here, create pack. Uh, you need to do self dot create pack.
Oh, I'm gonna have to do self on everything, huh?
Yes, sir. These are self here as well. The I think that should be good. Um,
Let's try it and see what happens. Oh no.
what was given? Go up. Game dot create pack. Line 98. Up. 98. What? Oh, okay. Create pack. Here, just delete this. You don't even need this function here. Just remove line 93 and 94. And then I want you to do a pack instance here. So delete this and just call the pack class, just like you did here, right? Pack, open and close parentheses. There you go.
Run it.
Yeah.
It's working again. There we go.
Okay. Ideally, you probably want to maybe add this to a data attribute in your init method, so it automatically creates it there as well. Either or, it's fine. But yeah, that's
Okay.
good. Let's go ahead and see your inventory class.
Okay, you want to see inventory?
Yeah.
Inventory, right here.
So good stuff. So that checks out. You have getter functions, which is perfect. I see you created a menu item list. That's not bad. Either. That should, yeah, that's fine. That's okay. I guess you're just trying to save some space below. Go up. And
This
then we
is
have.
this is just I had a clearing terminal because I was getting tired of seeing the same thing over and over. But
I
so
yeah, I was
pack
gonna
starts right there.
yeah, pack starts here. This checks out. I like your add item. So notice, guys, right? When he goes to add an item, first and foremost, he's gonna check if the weight of the item and the current weight added together is it less than or equal to the max weight, right? So you shouldn't be able to add something if the weight is over the max weight, right? And the same thing with volume, right? We have the current volume and the volume of the item, and then you add these together and make sure that it's less than your max volume. And then, and only then, also the slots, my bad. And then and only then do we add it into our inventory, right? So that was good. And then notice he's also increasing the weight and the volume because you have to take into account the fact that you now have an additional item. Current slots should does
Oh
not
yeah,
increase.
you're right.
Hmm. It
Never
didn't
ran into
break it.
slot issues. I guess I could have done a
Yeah.
lot of arrows.
Current slots, and then there you go. Then you have an else statements. In the event that for whatever reason, uh, if he's overweight, right? So if the addition of the item weight and current weight goes over, then he returns something else, pack overweight, or pack too full, or no more slots. So you have different conditions depending on what fails. That's good stuff. Yeah, I think it looks pretty good, man. We'll just skip the rest, but this should be the finished product for the most part. The show inventory, I like this right here. Uh, because you might have a large number of objects. If you guys try to print out an object, like I've shown you during class, and probably how you've already seen, when you try to print out the object, it's going to print out the weird string where it tells you like object and then it gives you like in location or at and it gives you like a long location in memory, right? To avoid doing that whenever you're trying to show your inventory, notice that he iterates through his list of objects, and as he grabs each list, he's checking the name, and he's doing a lot of different stuff here, but he's accessing the object get name method to be able to grab the name and use that to save it into some kind of object or not object, a dictionary, which he can then print out afterwards, right? So he uses this very strategically because chances are you might have multiple arrows. You might have 10 arrows. You might have two bows. You might have um, two swords. And that way he consolidates these items like items with like items, but also increases their counts depending if they appear more than once or only one time. Michael, we were just talking about this, right? Yeah, this kind of how you would like to do it. Make sure you're tracking how many items of each you have, and they're consolidated within each other. So yeah, this is a great way of doing this. Good work, Nick. That was great work. And if you
Thank you.
feel like for the rest of you guys, if you feel like, oh dang, like Nick's so much better than I am, Nick confessed to me that he's done stuff like this before. So don't feel
I knew it.
intimidated.
I knew it.
Yeah, no, this is like the object thing. It took me a while to get it. This is probably the fifth time I've seen it, and it's finally starting to make sense. So it's just a matter of practicing a whole bunch of times until it makes sense.
Yeah, so don't feel discouraged. But see, that's the reason why we're doing this. Because imagine you trying to do all this with it, like learn this all within a week and then get tested out in an assessment over the weekend. And now your grade is dependent on this. Like, yeah, maybe not the best situation to be in. So it's good that you guys are here and you're learning it now. So when you guys go over to the immersive program, you guys get a 100. But yeah, that's gonna conclude today's class. Tomorrow we're gonna continue with the official lesson. Uh where I will leave you with the some work for the weekend. But I'm gonna give you another assignment that's fairly similar to this. It's gonna be like some kind of game logic to make it fun. That's not on your PowerPoint or your curriculum. The ones in the PowerPoint curriculum are a little bland. I like stuff like this. I feel like this is a little bit more entertaining. Um, but we'll continue getting practice on this. You'll feel very comfortable. So by the time the immersive program starts, you're solid, right? You can focus on some other advanced topics for this. Uh, Before we actually go, let me show you something. Does anybody know the term or the subject or topic of inheritance?
Yes.
Nick, what do you know about inheritance?
Mm, if you have an object that has some properties and you make a sub-object based on that previous object, it will inherit a lot of the properties.
Right, and we'll talk a little bit about it much later as well. But just like Nick said, uh, you can create what we call a subclass or a derived class that can inherit from another class, right? How is that useful? Well, here we have an inventory item, and we know for sure that an inventory item should have name, weight, and volume. Uh, but isn't it kind of annoying that you have to keep creating these over and over again, or having to create some kind of list? What if you want a predetermined class that already has all these attributes but are specific to like arrow? So you can do something like class, where you do arrow, and you can inherit from inventory item. And then in the init method, and we'll talk a little bit more about it, but I'm just kind of trying to introduce you to this so you can, if you want to mess around with it. In the init method, instead of giving the arrow its own individual properties, what you do is you essentially you activate, in a sense, the properties from your parent class that you are inheriting from by using the command super dot underscore init. And notice that it's already letting me choose a name, a weight, and volume, right? It knows because I'm inheriting from the inventory class that arrow should have the same properties as inventory item. But instead, what I can do is I can say name is equal to arrow. I can say weight is equal to 0.5 and volume is equal to 1. And that's all. This is a whole brand new class called arrow with some predetermined terms. And I don't even have to rewrite these methods because arrow inherited these properties from inventory item. Who here has seen the show Invincible? Right? Invincible, he waits till his powers get activated or until he has his powers show up. That's kind of what the arrow class is doing here. You create the arrow class, you know that you can inherit some properties from your parents, but you have to kind of get them activated. And this is what this line of super init is doing. It's initializing the attributes that it's receiving from its parents, right? And this is a cool way to create a class that can have some very generic concepts, but then you can create a subclass that can inherit all these concepts and then even create additional stuff like shoot arrow, right? So, this arrow can have unique attributes, but in case you want to reuse other stuff from a parent class, you could do something like this. We'll elaborate more on this and how this works, but this is a way of doing it, right? What you guys could have done was something very similar to this. And done something like boat, right? And then you give it its name, and then the weights. You can create one for rope, call it rope. And now, when you're ready to create versions of these classes, all you have to say is bow1 is equal to bow. You don't even have to pass in any arguments in here because the class is already pre-established, right? And you save all this extra stuff of having to do all this crazy additional getter methods for each class because you inherit from inventory item, right? So it allows you to reuse code from other classes to create new classes, right? So I can literally create bow. I can say arrow1 is equal to arrow and just keep doing these, right? Have their own unique individual class that belongs to this version without having to do all the extra typing and having to create multiple lines where I'm creating an inventory item with unique items. It saves you a lot of code. It looks neater, right? And you're able to reuse stuff like this. Kind of going back to the concept of creating like a car class, and then you might have like a BMW, or you might have a F-150. You might have different versions of it. Everyone inherits from the same class of car, but there might be very unique specifications of a subclass. And that's all I'm going to leave you here with. I'm going to stop the recording.